Question 7.1. Explain why the reading on the voltmeter decreases as the brightness of the lamp increases. Well, naturally, the voltmeter should be constant, and if not, there must be an internal resistance, because what can change voltmeter is the internal resistance in the power supply. Brightness implies the current has increased. Increase in brightness will mean increase in current. As a result, increases the volt lost due to internal resistance. Also increases. Therefore, terminal PD decreases. What we're saying is that the electrode EMF of the battery is equal to the voltmeter of the resistor plus the internal resistor and the current. So if that current increases with the internal resistance, which means this is constant, that has to decrease. So therefore, if the electromotive force is constant and if IR increases, then V will decrease, and that's what happened. So question 7.2. The variable resistor is adjusted so that the lamp is at its brightest. The reading V1 on the voltmeter is noted. The second identical cell is then connected in parallel with the cell in figure 9. The new reading V2 on the voltmeter is noted. Explain why V2 is greater than V1. Right, so in this case, reduce current through each cell when the electromotive force is constant, therefore fewer voltage lost due to the internal resistance, and therefore the terminal velocity increases. Well, what we're saying is that the two cells in parallel behave as a single cell. So you have to solve this as a single cell with the same EMF, but with half the internal resistance or reduced internal resistance. This is what we mean by 1 over the total internal resistance is equal to 1 over R plus 1 over R, which means common denominator, R the numerator, and therefore R total, so you inverse, and R total will be R over 2. So the internal resistance will be half, and therefore the terminal voltage will increase.